Hey guys, welcome back to the channel. Today I thought we would give Advent of Code Day 2 a try. I haven't finished Day 1 Part B, which I'll probably just end up going back and doing at some point. But I thought I would give this one a shot just because I felt like doing it. So yeah, let's dive into it. Okay, so Day 2 is called Password Philosophy. And let's just quickly read through it and see what's going on here. Your flight departs in a few days from the coastal airport. The easiest way down to the coast from here is via toboggan. The shopkeeper at the North Pole Toboggan rental shop is having a bad day. Something's wrong with our computers. We can't log in. You ask if you can take a look. Their password database seems to be a little corrupted. Some of the passwords wouldn't have been allowed by the official toboggan corporate policy that was in effect when they were chosen. To try to debug the problem, they have created a list, your puzzle input of passwords, according to the corrupted database, and the corporate policy when the password was set. So, okay. For example, suppose you have the following list: 1, 2, 3, A, B, C, D, E, 1, 2, 3, B, C, D, E, F, G, and 2 to 9, C, all C's. Each line gives the password policy and then the password. The password policy indicates the lowest and highest number of times a given letter must appear for the password to be valid. Okay. For example, 1, 2, 3, A means that the password must contain at least A at least one time and at most 3 times. In the above example, 2 passwords are valid. The middle password CD is not. It contains no instances of B, but needs at least 1. The first and third passwords are valid. They contain 1A or 9C, whatever. Okay, both within the limits of their respective policies. How many passwords are valid according to their policies? Okay, so looks like we're going to be given a list of lines like this, and we're going to have to parse through them, figure out the policy, and then use it to test against this. So, I mean, a regular expression would solve this pretty easily. So we would just, every time I have to do a regular expression, I have to Google it because my brain just does not retain it. I've done them in like every single programming language and I just cannot retain how to do them properly. But it looks like a regex with just the basic, just stating that A needs to exist, for example, and have it repeat 1, 3 or 1, 2, 3 times. But that would find here. Let's just get into it and we'll see what we get. So let's get our input. So I'll probably just dump this into a source file like I did before. Okay, let's actually let me do this. We'll call it let's fire up Emacs day2.cpp. Okay, and then we'll have another one for compiling. Yeah, let's do this. Okay. Stream is always a must. Okay, so, and let's just get this compiling. Day 2, and we're good. Okay, now let's take, we already have our input actually. Let's paste that in here. And let's do, we should do okay, so that should put a quote at the beginning. For the not execute such a command. What? Get out of here. This thing's just being slow. Okay, so that put a double quote at the beginning of the whole thing, and now let's do one at the end as well. Let's say we'll do this at the end of each line. What did I just do wrong here? So that's going to form essentially just the items for our list, our input data list. Of course, it's still being slow. Okay, what just happened? It's still being slow. Okay. Now we're going to put this here, and we're going to say include string, include vector, and then let's just create a vector of strings. Let's save ourselves some time. Nope. We'll say a vector, a string, and then let's go here, do one of these. God, why is this editor being so slow right now? Okay, so we should have a bunch of strings, and as always, let's just quickly do s, and what do we call this? We didn't give it a name. Input. Let's call it strings. Strings, and then just do cout s and l, and let's actually compile, and then we'll compile it with day2.cp, so that should compile our code. Okay, and let's just rerun. Okay, so we have all of our input. So what we need to do is go through each string and parse out the policy part, and then parse out the actual password and test each password against the given policy. So okay, first thing, let's split these strings. Okay, we probably want to find, I always forget how to do this in C++. Split string. What's the easiest way to do it? Yeah, probably just find, and then you split based on the delimiter. Okay, so and then let's go first things first, auto. Let's find the colon. So the way we'll do that is, oops, what am I doing? Colon equals, we're going to say s.find, and we're going to put in, let's put this in, and that should give us if colon equal s.end. That means we found a colon, and then policy should be s.substring. Actually, what is it? What is string find C++? What does it return when it can't find it? It should be end. If no matches were found, the function returns, oh, end pause. That's what it is. Vectors return end. You can't. Okay, so s.end pause. Okay. Okay, now, actually no. Let's say, so if the colon was found, then we're gonna say the policy is gonna be substring, and then it's going to be the position of the colon, which is going to be the exact number of characters we want to read. So let's just say colon, and then string password is going to be everything after that. Substring, let's say colon +1, and that should give us the rest. And let's just do one of these just to double check. Policy, and no, and then we'll print password, and just see if we can print those out and make sure that we're parsing them out well. Oops, actually I'm going to do this and run it from within LLDB. Okay, so actually it should be +2 because we want to skip that space. There we go. Now let's just quickly double check the beginning, or no, let's go from the end. What's our input? Here's our input. So if we go to the end, or okay, let's look at this one. 5 to 6 G. Okay. Okay, good. So now we need to parse the policy. Okay. Parse out policy. And how do we want to do that? So the policy is going to be we could look at it this way. We can split it by space. I know I said I was going to do a regular expression here, I think, for this part, but I don't know if that's going to be too much fiddling. I think I might just loop through and count. But okay, so for this one, we essentially know that there's a space that's splitting the actual number of instances that we require of that character and the character itself. So we can just take the policy, split it by a space, and then here we can split both of them by hyphen, and then we'll get the min and max, and then we'll already have this part. So why don't we do that real quick and just brute force it that way. Okay, so we're going to take policy and we're going to look for a space. So policy, let's say size t space is equal to policy dot find. We're going to look for a space character, and if space not equal policy dot npos, then that means we found a space. And now let's say string, we're going to need, am I doing these checks needlessly for this? Okay, whatever. Then we're going to take the, let's say the range, let's call it the range, and we will say policy dot substring, and we're gonna go from the beginning to the space, and then the string character is going to be policy substring, and then we're going to go from the space +1, so we're going to skip over the space, and that's it, and that should give us the character range. Now let's do another cout. Let's just quickly verify. Actually, let's have some fun with a debugger. Let's put a breakpoint on line 1025. This printf debugging is annoying. Day 2, and then let's say 1025. Why? Oh, it's because I'm not compile, and let's just say -g, which will enable debug symbols, day2 dots, what am I doing? So that will recompile the program now with debugging enabled. Let's actually see if that worked. B day2.cpp, and we're, like we said, we're gonna go, let's go 1024 and step through. Okay, see, now it worked. Now there are debug symbols in our executable, and it's able to find the breakpoint we're looking for. Let's run it. Okay, so now I'm gonna actually extend this a little bit. Let's rerun that. Okay, now we can actually see what's going on a little bit more. So we have a break there, frame variables, which will show us the current frame in our current function, which is main. Sorry guys, there was a fire alarm just came on in my building, or the fire alarm test just came on my floor, so I had to do a little edit there. But anyways, I've done a video on LLDB. There we go again. They're doing fire alarm tests in my building right now, and they're testing my floor, so I might have to do a couple of edits here. Anyways, I've done a video on LLDB debugging, how to set breakpoints, how to navigate the frames and look at the stack and all that kind of stuff. So if you're interested, click on my channel, and I might actually leave a link down in the description linking out to that video, but I highly recommend it for people that want to learn how to debug with LLDB straight from the terminal, and it's a nice way to run your programs, especially if you're like me and you enjoy using just kind of a stripped down editor and don't want to use an IDE. It's a great way to run your program and quickly debug and test things and etc. Anyways, okay, so we can see our frame, our current frame. We have policy, this is what we expected. We have the password, so I think this is actually the first one in the list, right? 427Z, yes. And so it found space, right? This is the, let's do FRS, which will show us where we are. So we had just finished checking the for the space. Here we go again. They're testing. And now we have a breakpoint here, which is our which is going to grab our range. So if we just hit N for next, now if we look at the frame stack again, then we got the range, right? Or I could have just done P range, which will, oops, range, which will print that variable. And now, oops, FRS, we're gonna get the character, and because there's no line after that, it goes back to the beginning of the loop, so that's not gonna be very useful. So let's delete that breakpoint. We'll look at it after. Okay, now, so let's assume that we have the character and we have the range. Now, in order to parse the range properly, we should probably take the we should split it by hyphen and then take the first and second part, and that'll be our min and max. I apologize again for this fire alarm test that they're doing, but anyways, let's keep moving. So let's do this. We're going to do range dot find, and we're going to look for a hyphen, and then we're going to say hyphen. I think that's how you spell hyphen. Hyphen, yes. Okay, and now if hyphen not equal range dot mpause. Okay. Now we can then say, let me do this. Find hyphen and parse range int. Okay. And let us now let us now, so we need to take the first and the second part. So let's say, what's the C? There's A to I, so, or a toy, as I used to call it, is a way to take alphanumeric and convert to integer, but there's a C++ way to do it. C++ A to I don't remember. Is that all it is? We're just gonna have interprets an integer value in a byte string pointed to by replace toy with C++ equivalent of, okay, stoi, string to integer. If you don't want to use boost, C++ added. Okay, good. See, I always find new things when I'm doing stuff like this, because I'm just used to the C version of that. Okay, so let's say int min equals, and then let us take range dot substring, and then we'll say 0 to hyphen. That'll give us the first part, and now obviously we need to say s to I, and then int max equals toy range dot substring, and then we'll say hyphen +1 to go to the next one and to read the rest of the range, and that should give us the min and the max. Do we compile? What's the problem? Oh, oops. Is that all it is? Okay. Now, if we go here, can we put a breakpoint on that? And we want to say 1034. No, we can't. Okay, let's just be lazy. What's going on here? That's what's going on. Min, max, and then we'll say character, and then we'll say end line. So we should be able to do this. BRDEL. Okay, and I think that's everything. Let's quickly double check the last input. 12 to 20T, 4 to 8S, 5 to 6G, 12 to 20T, 4 to 8S, 5 to 6G. I think that should give us what we need. We now have all the information we need to do this. And now we can just check the password. And the simplest way to do that is table. How many characters are it? So the alphanumeric characters. Oh, I think they're coming in to check my fire alarm real quick. So okay, so I think these are going to be alphanumeric only, but let's not make any assumptions here. And let's just do, there's a total of 128 characters. So let's do this. Let's do a, oh, yeah, sorry about that beep. Okay, so there's 128 characters. I mean, they haven't really told us what type of, are they all just alphanumeric letters, or can they have special symbols? I mean, I don't think I saw any special symbols in here, but I'm not gonna assume anything. So let's just make some space. Do an array. what's the easiest way to do this? What I was thinking of doing is creating an array of integers for let's go with alphanumeric. I don't think that there's special input here. They don't mention it anywhere. Okay. Let's let's just do it the lazy way for now. Probably the safer way. Or go from 33 to, these are all, yeah, let's do that. We'll go character, well, these are the printable characters, I think. So there's a total of, let's go from 32 to 127. So that gives us whatever that is. So we'll just say or without del, actually we don't want del, 126. So we'll say const expr numchars is equal to 126. Actually, let's do this. We'll do tilde minus space. So that'll give us the number of characters between here and here, right? 126 minus 32 will give us 94, I think. 126 minus 32 is 94. And is that, am I calculating that right? Yeah, let's go with that. Okay, and then let's do a an array of ints. So we'll say counts and then numchars, right? So that will this initialize all of them to 0? I think it will. Okay, now, okay, so what we've done now is we made space for all of the characters, and we're going to count, and we're going to have an individual count for per character. And all we want to do now is loop through the password. So let's just go for ti equals 0, I is less than password dot length, and then plus plus I. So now we're going to go through each character in the password, and let's say let's just get a character. Actually, better yet, let's clean this up. For char c in password, that should give us, I think that should let us loop through character by character. And then so we have this array. So let's just say we'll take C. Okay, so we'll say const char index is equal to C minus space. So because space starts at 32, let's say we find the letter A, the index of this letter inside of our array will be 97 minus 32. So that will keep count in that element of the array, right? So then we can just say, we can say count char index plus plus. Will that work? What am I doing wrong? Let's do this. Okay, so that'll keep count of our passwords. Now, so this will go through every letter, and when it finds, not when it finds, it'll go through every letter and then increment that the count for that letter inside our counts array. So let's just run that real quick, make sure we didn't mess anything up to this point. Okay, it looks good. And I think this should initialize this entire array with zeros. I'm pretty sure. Initialize array to 0. I think we can just do that. So initialize all elements to 0, and C++ an empty initialization list will also, it's not allowed in C. Let's go with the one that I have chosen already. Okay, so yeah, so this will make sure that our array is zeroed out every iteration. And now let's just loop through our array, or better yet, we're only checking for one, so validate password. And now let's say bool is valid is equal to. Now, what do we need to check? We need to check if if counts at, and then we need the character, which, so this won't work quite like this because we can't use that subscript, right? We need to say char, no, let's just say substring and get a single, or no, actually let's substring this. We'll get a single character minus space. Will that work? That does, I think, work. And we need to check if char count, and that'll give us the count of the number of times the letter we're looking for has occurred. And then is valid will be if char count is more than or equal to min, and char count is less than or equal to max. So we have our range. And now let's just do some printf debugging here. Cout, let's print is valid, which will tell us if it is valid. And then let's get fancy, and then we'll say we'll print char count. Actually, let's do it this way. Say character, then let's put this in brackets. And then print the password at the end. Let's do policy, and we'll do password. And in that line, let's make this a little easier to read. Okay, so we're printing if it's valid. We're printing the character the count of that character, what the policy was, and what the password is. And then this should be able to tell us, this should help us verify. So, okay, let's look at this one. Actually, this one's too much counting. Let's look at this one. 0 to, oh no, I'm reading this wrong. So this one failed. It required 4 Gs. No, yeah, we found 4 Gs, but we needed 5 to 6, so it failed. Here, we need 3 W, no, I keep reading this wrong. We have 3 Ws, but we needed 5 to 6. This one passed. We needed 11 to 12 Gs. We have 11 Gs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, beautiful. It looks like we're actually working here. We got 3 Ds. We can see that. 1 to 2 Ds, but not 3. So we're not in good shape. Okay, so let us, and what did they say? How many passwords were valid or were invalid? What do they want? How many passwords are valid according to their policies? Okay, so then let's just say int num valid equals 0, and then if is valid, let's just say num valid, and then cout number of valid passwords, and we'll say num valid and line. Let's rerun that. 396. Okay, I think this might work. I think we might be done. Let me quickly double check. The above example, 2 passwords are valid. Blah blah blah. Let's see. Okay, let's just try it. That's the right answer. Woo. Okay, we're good. Okay, so let's do part 2. While it appears you validated the passwords correctly, they don't seem to be what the official Debugging Corporation authentication system is expecting. The shopkeeper suddenly realizes that he just accidentally explained the password policy rules from his old job at the sled rental place down the street. The official Debugging corporate policy actually works a little differently. Each policy actually describes 2 positions in the password, where 1 means the first character, 2 means the second character, and so on. Be careful, Debugging corporate policies have no concept of index 0. Exactly one of these positions must contain the given letter. Other occurrences of the letter are irrelevant for the purpose of the, okay. Okay, I see. Okay, so the way that they're doing it, exactly one of these positions must contain the given letter. Other occurrences of the letter are irrelevant for the purpose. Isn't this easier than part 1? All you're doing is you're making sure that either 1 or 3 has the right letter, right? So they're saying the first, so we can just convert this to an index. So position 1 needs to be A, or position 3 needs to be A, but not both, right? So here position 1 is A, so it's valid. 3 is C, but we don't care. 1 was valid. Here they're saying that we need a B in position 1 or 3, but we don't have one in either place. Here, positions 2 or 9 need to be C, but not both, right? Here, position 2 is C and position 9 is C is what they're saying, so it's invalid. It has to be one or the other. So, okay, so that's pretty straightforward. How many passwords are valid according to the new interpretation? Okay, so let's quickly look at our code here. We can repurpose most of this, and we can just repurpose most of this. Validate password. So let's just do this for now. I was going to refactor this and clean it up, but I don't give a shit. Let's just use the data that we have on hand and validate the passwords. So the first thing we'll do, const is pos or index1, no, size t index1 equals min minus 1, because they're essentially giving us a number of the letter, not the index, right? So we have to be careful, right? Have no concept of zero index, which essentially just tells us to subtract 1. And then we'll say const size t index 2 equals max minus 1. Okay, so now we have the indexes of both. And I think all we have to do is check if one or the other are the letter that we're looking for. If both, okay, let's just say, let's actually check for the invalid cases first. What's the easiest way to do it? We'll check yeah, let's make sure that they're both not there. So if what is it, password at index 1 is equal to this is annoying. Let's just say, do we have that somewhere? Space +1. I would prefer to work with a char rather than a string when we're looking strictly for a char. And then here we can actually compare it. Character and password at index 2 is equal to character. Then invalid, both indexes contain letter, right? So that's invalid. And else, so else, then we just need to check if, else if password at index 1 equals character, or or why is it doing that? This is so weird. Password at index 2 equals character. Did I do something? Does this compile? Yes, it does. For some reason, oh no, it's, we'll do it like that. Okay, then is valid what the hell is going on with my Emacs? Fucking piece of shit. Let's just say num valid plus plus. Let's do that. And compile. Good. Okay, is there? So if index 1 is the character and index 2 is the character, then that's invalid. We don't count. But once we rule out that case, we can check if one or the other are the character, and if they are, then it must be valid because we already checked if they're both, and they're not. But if this boolean holds true, then it must be one or the other that are the character, and then we should increase our count of the number of valid passwords. And obviously we're not going to get in here if neither of them are, so that would mean an invalid password. So I think we're capturing everything here. How many passwords are valid? Okay, so I think I did it right. Compile, run, 428. I'm nervous. But we got it right. Okay, that's day 2. That was easy. I always have to refer to things and look things up when we're dealing with strings, just because my brain does not like to retain string and regular expression related content. But I think that was pretty straightforward. I hope that was interesting, and let me know your thoughts down in the comments. Let me know if you did it, how you did it. Of course, I can obviously go through this and clean it up and make it a little bit more straightforward, and probably speed it up with other algorithms, but we got the right answers, we got the stars, that's all that counts. So yeah, see you in day 3's problems. Bye.